everyone. Today we're going to be talking about ellipses in section 9.1. So as you can tell by this picture here in front of us, an ellipse is very similar to the shape of an oval. Okay, we are going to keep calling it an ellipse, but yes, in general it is going to look like an oval. We have actually talked about an ellipse in the past in reference to a circle. However, it's got a slight difference in a circle, and so we will go over that today. All right, so for an ellipse, it is the set of all points P in a plane, the sum of whose distances from two fixed points, F1 and F2, is constant. Those F's, as stated here, are going to be called the foci, plural for focus. So these points on the inside of the ellipse is going to be the foci. Similarly, the midpoint of the segment connecting the foci is the center. So if I were to have a segment connecting from one focus to the other, then the midpoint right in the middle is going to be the center. All right, so things to think about when we have an ellipse is we're going to still have a center point, just like a circle. We are also going to introduce a focus, or in our case, we have two of them, so we are going to have a foci, something the circle did not necessarily have. So we will talk about that today. Let's go ahead and take a look at the standard forms of the equations. We have two of them, and if you pay close attention and you just look for the similarities and the differences, it all pertains to those denominators. The a squared and the b squared get flip-flopped. But what's important is the variable in which they are underneath. That is going to tell us exactly how to graph our shape. So if you take a look at the first example, the a squared is located underneath the x. And what that means is that our ellipse is going to run along the x-axis. So our ellipse is actually going to end up being the biggest in regards to left and right. Whereas in the second example, our y squared has the a value underneath it. Therefore, our ellipse is going to run along the y-axis, which is up and down. All right. So some things to kind of just get a sketch going. This is one of those lessons where practice is going to be key. So right now it's a lot of illusion, a lot of just abstract thinking, and then we'll get into some actual examples. All right, so bear with me as we go through some of these just to get an idea of what an ellipse will actually look like and what it actually tells us. So to get started, again, similar to the circle, an ellipse has a center. And just starting basic, our center is going to be at 0, 0. It's going to stay at the origin. Okay, and then we're going to have vertices and co-vertices. So the vertices are going to be the longest side. We're going to call that the major axis. Major meaning biggest, and in our case, we're going to say longest. Okay, we've already kind of touched on this already, but it's the side with the a squared. So again, if a squared was paired with the x variable, then my major axis is going to be along the x-axis. If it was paired with the y variable, then my major axis would be along the y-axis. Similarly, we got vertices and then we have co-vertices. Those are the runner-ups. So if it's not the major axis, then it's got to be on the minor axis, the smaller of the two. And again, if a squared's already taken care of, then this is going to be the one that pairs with b squared. All right. So just to get an idea here, if I know, for example, question 1, or just this example in general, my origin is at 0, 0. I'm going to just go ahead and mark a space 5 units to the right. Again, just abstract. If one's 5 units to the right, then I'm also going to go 5 units to the left of the center. And I'm going to call that a, 0 and negative a, 0. Again, we know that they are actually 5 because we measured that, but that's not necessarily going to be the case right forever. Okay, so the longest side is going to be the a's. The second longest side, the minor axes, are going to be the b's. So I'm just going to go up 3 units. Anything else, as long as it's smaller than 5 on this case, then I know that I'm in the clear. I'm following the rules. Actually, I labeled that one wrong. Should be 0b if I'm on the y-axis this time. And then 0, negative b. And then if we go ahead and connect the dots, you will notice that almost like a football shape kind of thing forms, or in other words, an oval. That is our ellipse. All right. Now again, some things to make note of. The major axis is going to be the longest one. So the major axis going straight through the center, touching from negative a to positive a, that is the major axis, this length here. Then we have the minor axis, which is the shorter of the two, and that is this one here. All right. And last but not least, we are introducing a new feature of our graphs, and that is the focus, or in our case, the foci. The foci, just like the picture up above, they're going to be the points inside of the ellipse whose distance is on the plane. Okay, they share a midpoint. They kind of just give us extra information, and we will actually be using a focus more often in the rest of our notes. So it's good to kind of get a little basis here, and it's actually used in an ellipse. So that formula is actually going to look very, very similar to something you guys have seen in the past, just one tiny detail. It is very close to the Pythagorean theorem. However, my Pythagorean theorem tells me to add my a squared and b squared, but when in regards to an ellipse, I need to subtract them. All right, and what I need you to make key of here is that your c value is the distance from the center every time along the major. Let's spell that right. The major axis. Okay, so in this case, if my major axis was along the x-axis, then I need to make sure that my foci are also along the x-axis. All right. So we're going to do the same thing now, but we're going to mix up our a's and our b's. Same idea. This time, my major axis is actually going to be with my y's. So with the same thoughts, I'm going to label a point A. Fix that there. I'm going to label a point A 5 units up this time. And I'm going to call that 0A. As well as 5 units down. And again, the reason why this is going up and down this time is because my A squared is paired with my y. A squared is always going to identify the longest side. And since it was with y, then that tells me I need to be along the y-axis. Oh, I think I did 3 last time. Let me check. Yes, 3. So then I'll do 3 this time again on the x-axis because that is the smaller one for this problem. And I'll go ahead and draw my ellipse. And just notice the difference between the two. One's going left and right. Again, it's not the perfect graph, but it's all right. It gets the point across. While the other one is going up and down. The center is still at 0, 0. The major axis is still paired with A, but this time it's going up and down. And again, the focus or the foci, since there's plural, since there's 2 of them, is still going to be the same formula. A squared minus B squared. This time, however, my foci are going to land along the y-axis, whereas last time they landed or should land on the x-axis. All right. So before we get started, let's think about key features of an ellipse. We talked about key features with the circle, so let's go ahead and identify key things for an ellipse. Looking at your standard forms, they are both always equal to 1. So that is one thing that's always going to be needed. They need to always equal 1. You will always be adding. something that's similar to the circle, is you're always adding. And then the coefficient is still going to be a 1 on your x squared and y squared in the numerator, but you will have denominators. So necessarily the coefficient won't always be 1, but you definitely want a 1 up top there with the x's and the y's. So this one is an introducing denominators. Not always, but most always. All right. And again, key features, the A value is always the longest side. A value is always the longest, whereas the B value is always the shortest. And then to piggyback off of that, whichever one has the longest side goes with the same axis. So longer / shorter side pairs with your XY axis. We'll talk more about that as we go through some examples here. All right. Now the only added feature that we haven't discussed are the letters H and K. Again, very, very similar to the circle equation in that it's our center point. Okay, again, noticing how your H and your K are both going to be opposites because of the formula introducing a minus and a minus. So if I were to ask you for all of the features of an ellipse, you would start off by telling me the center. That is your HK. Again, opposite from what you see. Then we're going to head into the vertices. Vertices, again, are going to be those points on the outside of the ellipse, the points that you are going to get from your A and your B value when they get square rooted. Now, pay attention to this formula here. My A squared, my longest side, is paired with my X axis. So when I go to find my vertice, it's going to affect my X value. So I'm going to still have my center of H, but then I'm going to add and subtract my A value, whereas my K will stay the same because my vertices is the longest side. And I know that that pairs with my A. Similarly, if my vertices are taken care of, then I'll have my co-vertices. This time my co-vertices is paired with the letter B, and that matches with my Y. So my H on my center will stay the same, but then my Y or my K is going to be affected by my B. Again, abstract information, we'll be starting to work with numbers and it'll kind of come around and make some more sense for us. And last but not least, the last thing we need to understand or we need to include are the foci. We can get those by the formula c squared equals a squared minus b squared. And as soon as I find my c, that is what you are doing here, is you are looking for your c. As soon as you find that, it is going to include a foci on either side of your center point, and again, along the longest side. So if this one was along the x-axis, so I'm still going to have center H, but then I'm going to add or subtract my C value. And then K will stay the same. So all of this information, let me throw an example at you with this graph here. I'm going to tell you that we have x minus 3 squared plus y minus 3 squared. The denominator on the x is going to be a 36. The denominator on the y will be 9. And it will be equal to 1. Before I get started, I'm going to make sure that I am in fact working with an ellipse. Both my x and y's are getting squared. I'm adding them together. But more importantly, they are equal to 1 with those fractions in the denominator. So to get started, I'm going to follow all of this information that I've labeled over on the left side. My center point is going to be at 3, 3. It just so happens that they both X and Y is at 3, 3. That's all right. We'll work with it. I'm going to go ahead and label my 3, 3 on my graph. And then I'm going to identify the longest side, which in our case here, the longest value in the denominator was 36. That is my a squared value. So if a squared is 36, then that's going to tell me that my a is 6. What that tells me is that it's paired with my x coordinate, so I need to go back to my center point, and I'm going to run along the x-axis going left and right, and I get to go 6 units left, plot a point, go back to the center, 6 units right. So that's going to put me at 9, 3. Just going to eyeball here, 4, 5, 6, 7, 8, 9. 9, 3 to the right. And if I go to the left, it's going to put me at -3, 3. So that's taken care of. Again, you just graphed your vertices. You took your center, which was 3, and then you added and subtracted a 6 with your y still the same. So that gave you, like I said, 9, 3 and -3, 3. Yes, this is the way I would prefer that you write it, but just to get an idea of these actual formulas that we did just a second ago, that is what you are doing. After we have our vertices, let's go ahead and find the co-vertices. That's going to be your b value. So we took care of a. The smaller of the two is going to be my b squared. So that tells me b squared is 9, therefore my b, my single b, should be 3. That now tells me that you are going to affect your center point, and you're going to go up and down again because it is paired with your y this time. And go up 3 as well as down 3. If I were to plot my points or make my picture, label my co-vertices, that puts me at 3, 3 plus or minus 3, which would end me up at 3, 6, as well as 3, 0. And you can see and confirm that information on the picture. Last but not least, go ahead and make my lines, creating my ellipse. And again, I was a little early, so this time the last but not least is my foci. I'm going to do my formula up here. We got c squared equals a squared minus b squared. Remember, it's slightly different from your Pythagorean theorem. I already know what my a squared is. It's 36, and my b squared is 9. So if I were to plug that into my formula, that's going to tell me that my c squared is 25, but I'm not solving for c squared, I'm solving for c. So I take the square root, and that tells me that it is a plus and minus 5. Remember, when we square root both sides, we take the plus and minus version. What that information tells me is I'm going to go back to my center. It is going to change and shift along my x-axis. So it is changing my original x value on my center by 5 values, whereas my y will still remain a 3. So if I were to graph my foci here, it's going to be slightly in front of that vertice and slightly in front of this vertice as well. And there we have it. Those are our foci. And if I wanted my true coordinates, those would be at 8, 3 and -2, 3. All of this information pairs with an ellipse. So let's go ahead and try the next one. Again, the only difference for this one is that my A and my B's were changed. So this time my longest side should be along the y-axis. All right. So I'm going to go ahead and give you the same exact function. The only thing now is that my center is still going to be the same, HK. But when we talk about our vertices and co-vertices, those are going to be changed a little bit because my A and my B are swapped. So my vertices, my H will stay the same because my longest side is no longer on the x-axis, it is now actually on the y-axis. So my vertices is going to be a H comma K plus or minus A, whereas my co-vertice will be H plus or minus B comma K. Same thing for your foci, that function does not change. C squared equals A squared minus B squared. But this time when I go to find my coordinates, again, because my vertice line, because my major axis is on the y-axis, it is going to affect my foci with my K. All right. So we'll give you the same kind of function here, but this time I'm just going to swap out my A and my B. So this one will now have 9, whereas my Y now will have 36. Again, labeling your center to get started, 3, 3. Your vertice, and if you need to graph this before you find all your vertices and co-vertices, that's kind of my method. That way I can kind of pull my values and my coordinates from the graph and I don't have to worry about all that math function. This is my A squared this time, so that tells me that I need to go up and down a measure of 6 units, putting me at 3, 9, and 3, negative 3. Trying to get as many good points here for you as I eyeball it. Followed by my co-vertices, which is my B value, giving me a B value of 3, pairing up with my X coordinate, so I'm going to go left and right, this time 3 units, putting me at 0, 3, and 6, 3. Draw my little football, my ellipse, probably should call it an ellipse. And then my foci following my function. Same idea, 36 minus 9, which gives me 25. And when I square root both sides, my foci is telling me I'm going up and down this time from the center, going along my major axis, going up and down 5 units. Putting me at 3, negative 2, and 3, 8. And there you have it. Our center, our vertices, our co-vertices, and our foci. So if I had any words of wisdom, I would say start memorizing the features of the graphs, of the figures, of the shapes. Notice how an ellipse has a center. A circle also had a center. But what a circle did not have was vertices and co-vertices, nor did it have foci, so that is all new information to us. Center, vertices, co-vertices, and foci. Major axis, minor axis, also pairs with an ellipse. So we just have a few more examples on graphing these, what to expect, when we can graph, when we can't graph, things like that. So looking at question 1, I'm telling you that this is an ellipse, but don't just trust my words, I want you to verify, all right? To get started looking at question 1, if I were to check through all of my boxes and double check and make sure it follows all the criteria that I've listed right here, for starters, it does not equal 1. So it's not saying that the game's over and I can't keep going. I have to get it to equal 1. So I look at that 400 and I say, well, the only way to make that equal 1, that is doable across the board for everything, is to divide. Okay, yes, I can technically subtract by 399, but that would make you also have to subtract it to the left-hand side. We don't see random numbers, random constants on the left-hand side when it comes to ellipses. So my next best option is to divide. And whatever I do to one side, I need to be sure that I do it to the other. And in fact, I need to do it to everything on the other side. This will now simplify for me and give me an x squared over 16 plus a y squared over 25. And what do you know? It now equals 1. This is an ellipse function that I much prefer. So I've got everything ready to go. This is the function I need. Now I'm going to start making my picture. So to get started, I'll find my center. I don't have any parentheses up top with x and y, so I'm going to say that my center is at 0, 0, which is nice. All right. As you gain information, go ahead and label that information on your graph. Then before we continue, I need to figure out and determine which one is my major axis and which one is my minor axis. And again, it pairs with the words. Major, think big, think longer. So we are going to look and see that 25 is the longer number or the bigger number, and that is always identifying my a squared. Well, with that a squared, I look up and I see that it's with the y variable. So that tells me that I'm going to have my major axis on the y-axis. And in fact, that's going to take me up and down 5 units from the center. So I'll go ahead and put my points up 5 units from the center, down 5 units from the center. And there we have it. That is our vertices. We got 0, 5 and 0, -5. Remembering this is my major axis, the longer side. After our vertices, we'll go in and we'll find our co-vertices. So we're going to need the smaller of the two. Looking at the 16, that is my co-vertice value. That's going to tell me that my b this time is going to be 4. And it's paired with my x coordinate. So I'm going to go left and right back to the center, left and right 4 units this time, putting me at -4, 0, and 4, 0. As soon as I got those 4 points, I'll go ahead and connect them, creating my official ellipse. And the last thing I will need is my foci. Using the formula, c squared equals a squared minus b squared. Plugging in our a, plugging in our b, giving me a 9. Of course, when we square root it, it's going to give me a plus or minus 3. Pausing for a second just to remember where that 3 is telling me to go. Is it going up, down 3 or left, right 3? And again, the major axis told us it's on the y-axis. Therefore, I should be going up 3 from the center and down 3 from the center. And that is the official graph of an ellipse. Heading down into question 2, if you want to try this one on your own and take a look at my teacher notes, please do so. Key features, again, noticing which one's the longer side. Before you even get started, finding the longer side is going to help gear your picture so you can kind of get an idea of what's going to happen. That 9 is paired with your x variable, therefore your longest side, your major axis, should be along the x-axis, should be going left and right. So again, give that one a try, pair it to my teacher notes, see how you do, and let us know if you guys have any questions. We're going to head into word problems, all right? This is probably the trickier part of all of the sections. Again, because it plays a role in can you remember the parts of each figure. An ellipse, we talked about major axis, minor axis, and then we have vertices, co-vertices, and foci, not to mention a center. A circle also has a center. So if I say something has a center, you haven't eliminated your options yet. You need that additional information that's different to allow you to understand that we are in fact talking about an ellipse. So besides the fact that the directions actually tell us we're working with an ellipse, you will see questions like numbers 1 and 2 on your test that don't necessarily tell you what figure you're working with. So pay close attention to those words. To get started on these types of questions, a graph is best. When in doubt, graph it out. If you can get some sort of picture, that's the best option to do. So I'm going to go ahead and plot the information they gave me. I'll just do it off to the side. They said that my foci is at -1, 0, as well as 1, 0. Remembering foci. Foci are always on the inside of my ellipse. And then they told me that my vertices are at +2, 0 and -2, 0. That's the only information they just gave me. So if I were to just draw a quick picture, my ellipse might look something like this. Okay, it's definitely going left and right, so it's pairing with my x variable. That's going to be my major axis for 2 reasons. It's my vertice, and my foci lie on it as well. So this tells me that it's my major axis. In other words, I need my longest side to be paired with my x variable. So I'm going to get my formula started. I always know that it's an x something squared plus a y something squared. And I know it always equals 1. I'll worry about the squareds in just a moment because what we haven't done yet is found the center. Remember, the center is a direct midpoint from either the vertices or the foci. It should be the same midpoint for both. So if I were to look back at my little sketch here, the center is going to be right at 0, 0. So I could say x minus 0 squared and y minus 0 squared. Or I could just say y squared and x squared. Whichever you prefer is fine. All right. Now the only information I don't have yet are those denominators. Well, I do know that my x variable is my major axis. Okay. So I know that my major vertices from the center is a total of 2 units. And so if I were to take that entire piece, that is telling me that that is A. And if I were to square that A, that is now going to turn it into a 4. So I'm going to go ahead and put a 4 there. The only other bit of information, they did not tell me the height of this ellipse. They did not tell me the B value. I have to find that. But what they did tell me was my C value. Again, from the center to my focus, either one of them, my C value was a total of 1. So I know that my C is 1, my A is 2. If I plug it into my focus formula, and I square my values, I can find my B, or in our case, our B squared. 1 equals 4 minus B squared. Subtract that 4 over, gives me a -3 equals -B squared. And to make things look much nicer, I get rid of those negatives on both sides, and I now know that my B squared equals 3. I'm not solving for B, I'm solving for B squared because that is what needs to live underneath my y squared function. And there you have it. There is the equation of our ellipse. All right, heading into question 2. Again, more vocabulary, more ways of understanding the differences. If this question, without telling you this was an ellipse, if this was given to you on your test, could you make sense of it? All right. Best way to make sense of something? Make a picture. Doesn't have to be perfect. Just get an idea going. I'm going to graph my center first. That way I can get kind of a basis going. 2, -3. Then it tells me that my major axis, again, major pairing with A, minor pairing with B. My major axis is vertical. That's another huge hint. And it's a length of 20. Now, it's a vertical length, meaning it's all the way up and all the way down a length of 20. So that means if I were to go up and down, I'm not really going up and down 20 each way. I'm actually going up and down 10 units each way. making that 20 official. Okay, the total length should be 20, but half of that should be 10. So that's going to tell me that my A value is 10. Then I'm going to do my minor axis, which they didn't tell me that it was horizontal, but if I just took care of my vertical, then I must know that my minor is going to go the opposite direction, so it's going to be horizontal. It's a total of 10 units, therefore if I split that in half, it is 5 and 5. Therefore my B value is 5. And again, here's your ellipse. If you could just do a decent little sketch here. Does it qualify all of the rules? Is your center at 2, -3? Does it have a vertical length of 20 on your major axis? And does it have a horizontal length of 10 on your minor axis? And if that is the case, all we need to do now is write our function. So we'll start with x, add our y, set it equal to 1. There's no particular order necessarily. You could always do x squared plus y squared, or you can flip-flop it and say y squared plus x squared. Because it's addition, that order does not matter. I just prefer to keep x and y's together. So we're going to play a role of our center. We have a center this time, so I need to make sure that is a key role in my function. If I plug it in, I'm going to have x minus 2 squared, a y minus a -3. Well, what's going to happen to that? It's going to make it add. So it's going to turn into a y plus 3. Last but not least, labeling my a squared and b squared. Again, my major axis paired up and down, so it must go with my y. And if I square that a, that gives me 100. My minor axis pairing with x goes left and right, gave me 5. And when I square the 5, I should get 25. All right. Last but not least, we're going back in time. We are going to need to complete the square. This is a process, something I need you guys to practice more and more of. Maybe even replay this section of the video to get an understanding of what we're doing and why. All right. For questions 3 and 4, I'm essentially asking you to clean them up. I need the actual equation. All right. I'm telling you there is an ellipse happening. It's just a matter of I don't know anything about this ellipse because it's not perfectly squared. I don't have all that extra information. I need the fractions going. I need it equal to 1. I need all of that. So to get me started, I'm going to rearrange the terms. I'm going to put all my x's together, just rearranging it. I'm not changing a thing. I'm just going to put all the x's together, all the y's together. That 11 will stay there for the time being. Just like when we did solving by elimination, when we did partial fractions, then we're going to take a look at the GCF between the variables. So for my x variables, the GCF was 9. I'll go ahead and take that out. For the y variables, the GCF was 4. Take that out. 11 still staying. All right. Now, I can have x squared minus 2x, great, but what I need is to know the exact center point. I don't know that, so I need to remember how to complete the square. And that, again, is the formula b over 2 squared. Your b value is whatever that extra chunk is. So, if I were to consider my x's for a minute, oops. Not x squared, x's, I have x squared minus 2x. Well, your b in this case is that extra piece, that term all by itself. So if I go to complete the square, I'm going to plug in a -2 over 2, and I'm going to square it. That's going to give me a -1 squared, which gives me a +1. This +1 is what I'm going to add in those parentheses to make it give me a perfect square. So what's happening? I got 9 parentheses x minus 2x, and now I'm going to put in a +1. All right. Now think about what that just did to the equation. You just put in a +1, But in reality, you had this 9 already out front. So you didn't really add a 1, you actually added a 9. Okay, now we're going to leave the 9 where it is, but we need to remember you just added a 9 to the left side, so you technically also need to add a 9 to the right side. Again, that goes with whatever you do to one side, you have to do to the other. If we just added a 1, we have to remember there was still a 9 in play here, so it needs to still get added to both sides. Now let's try it with y. I took out my 4. I'm going to leave my y squared plus 4y, and I move over to the side. Now this is my y's. Think about your extra piece this time. The extra is the 4. If I plug it into that complete the square formula, I get 4 over 2 squared. Well, 4 over 2 gives me 2, and when I square that, I get a 4. Again, that 4 is what we're going to add to that set of parentheses with y, but I didn't really add a 4, I actually added a 16. So I need to remember to also add a 16 to the right-hand side. Again, whatever I do to the left, I have to do to the right. Just make sure you're paying attention to that coefficient out front. So now, that 11 is no longer 11, it is actually going to be 11 plus 9, which is 20, plus another 16, which gives me 36. So I got a new number on the right. Now we can factor. The whole point of completing the square is to make those parentheses factorable. So I say, what two numbers multiply to get me 1 while also adding to get me negative 2? Well, that is an x minus 1, or simply x minus 1 squared. Do the same thing with my y's. I need two numbers that multiply to get me positive 4 while also adding to get a positive 4. Well, those two numbers are the same, and it's a plus 2. See how this function's kind of coming together now? I have my x minus 1 squared, my y plus 2 squared. I have that center point getting ready to go. The only thing I have left now is I need it equal to 1. So in order to get that 1 to happen, I need to take that 36 and divide it. Making sure to divide everything by 36. Giving me x minus 1 squared over 4 this time, plus y plus 2 squared over 9, and what do you know? It equals 1. Double check, make sure you fit the criteria for an ellipse. You have your x and y squareds. They're both equal to 1. You have no coefficient in front of the x and y's, but you do have that number down below. Those numbers will represent your a's and b's. So again, the question's not asking you to graph this, but if you were, think about your longest side, your major axis. Think about your shorter side, your minor axis. Your vertices, your co-vertices, your foci, as well as your center. All right, if you need to, if you have space, maybe just draw a quick sketch just to get that practice in. I'm happy to check that. And I'm going to have you guys try number 4 on your own. Again, my teacher notes are posted. There's plenty of explanation on the teacher notes. And again, if you need to, feel free to come and ask your questions. So try number 4, see how you do, practice completing the square.